Okay, thank you. Just 1 minute. I try to. Yeah, fine. So let's start the session. So in last class we were discussing about some of the problems from probability random variables random process, right? Like the before last week few people have some of you have requested about solve some previous questions from a random variables random process. So we were, I think, starting solving some questions in the last week. So we will do few more questions from that, and after that some questions from signals we'll see. And also there one student sent a question from a state space analysis. If possible, we'll see that because some background I need to give for that before explaining that question. We will see. So see this question. This question was given in GATE 2021 ECE question 2 marks. The question is a box containing the following 3 coins: a faint coin with head on one face and tail on the other face. So you can say 3 coins are there. So the first coin is a fair coin. So the first coin is first coin is a fair coin, so head and tail both will be there. And second coin, a coin with heads on both the faces, so head and head on both the faces. And the third coin is tail on the both the faces. So first one is a fair coin. Fair coin means, you know, right? So it will have equal probability of head and tail. So they're asking if the coin is picked randomly from the box and tossed. So we have some box. In this we have 3 coins, 1 2 3. If a coin is picked randomly from the box and tossed, so what is the probability that, okay, let us first understand the question. Out of the 2 remaining coins in the box, 1 coin is then picked randomly and tossed. If the first toss results in a head, the probability of getting a head in the second toss is. That means, so 1 coin is picked and tossed, okay, randomly. So let us say the first coin is resulted head. Okay, now they're asking what is the probability that from the remaining 2 coins, 1 coin is already picked. From the remaining 2 coins, 1 more coin is picked and tossed. So what is the probability that you get a head in the second one also? Okay, you understood? So 1 coin is, they have said, randomly taken and picked up. So if the first coin is resulted in head, what is the probability that the second coin is also head? So let us say we assume something. P of A is probability that first coin is head, resulted in head. First coin is resulted in head. Sorry, not A. Let us say A is the event that the first coin is resulted head, and B is the event that the second coin, when it is tossed, picked and tossed, it is also head. Now what is given is P of A, first coin tossing, second coin tossing, second toss. A is already head given. That means if given A is head, what is the probability that B is head? already given A is head, then what is the probability that second coin is resulted in head? Now, so can we write this from Bayes theorem? Can we write something like this? P of B given A. A means the event that the first coin is when it is tossed resulted in head. B is the event that the second coin when it is tossed resulted in head. So given first coin is head, what is the probability that second toss also head? So given A, what is the probability that the second toss B is head? So this, can somebody tell me what is Bayes theorem? This we can write from Bayes theorem. P of A intersection B by P of A. Can we write this? P of A intersection B by P of A. Okay, that means what does that mean? What is the total probability of getting a head in the first one? That is in the denominator. And what is in the numerator? The intersection of getting a head in the first one and getting a head in the second one. Okay, so A is what is the probability that you will get a head in the first toss. If you get a head in the first toss, in that what is the probability that you will get a head in the second toss? Fine. Now first we will calculate, if we can find out this, then what we require, that is the answer. So what we do, we will try to find out P of A. Can somebody tell me what is P of A? Please feel free to unmute your mic and tell me. So P of A is probability that first coin is head. First toss is head. Now in this, if you see in the box, we have 3 coins. So 1, 2, 3, let us say in 3 coins. When there are 3 coins, what is the probability, with what probability we can pick a coin? 1 by 3, right? When there are 3 coins, with 1 probability we can pick a coin, right? So to get a head, what are the coins we should pick up? Either first coin or second coin. If you pick the third coin, we cannot get a head, right? So are you able to follow me? Can somebody please unmute and yeah, fine. Yes. So either you need to pick a first coin or the second coin. Third coin, if we pick also, there is no use. So what is the probability that we will get a head? P of A, I am writing here only. So P of A is, suppose with 1/3 probability you picked first coin. You picked first coin. With 1/3 probability we picked first coin. Okay, that is probability of picking a coin. Now once you pick a coin, first coin you have picked, then you tossed it. Then what is the probability of getting a head, since it is a fair one? 1 by 2, right? Since it is a fair one, the first coin, if you toss the coin, either you get a head or tail with 1 by 2 probability, right? So to get a head, you have to pick the first coin, and that is 1 by 3 probability, because 3 coins are there, 1 you are picking, and with 1 by 2 probability you will get a head. Or there is also another possibility. You can pick the second coin with 1 by 3 probability, right? So what is the probability of getting a head here? Can somebody tell me? I picked a second coin, sorry. So what is the probability with which I can get a head now if I toss the second coin?
1.
Yes, it is 1. Because both the sides it is head, it's unfair coin, obviously we'll get 1. Yes, Now let us say you picked the third coin, so that is also possible. Let's say you picked the third coin with 1/3 probability. Now what is the probability that you will get a head when you toss the third coin? 0. That means to get a head in the first toss, either you have to pick the first coin or second coin. So what is the total one? You will get 1/3, 1/6 plus 1/3. That is how much? This is 2/6. Let us say 3/6, right? 1/2. Is it correct? So 1/6 plus 1/3, 2/3, 3/2, 1/2, right? P of A is 1/2. Now P of A we have. Now P of A intersection B we want. That means what? If P of A intersection B means what? So P of A intersection B means the first coin is head, already we know. So first coin head, already we know. The second coin also must be head. Second also must be head, right? That is P of A intersection B. Now again, what is the probability for getting first coin head? Already we have seen, with 1/3 probability or half probability. This one, first you have to select a coin 1/3. Let us say first coin you have selected with 1/3 probability. Now, or else let me enter here. Yeah. So P of A intersection B, I'm writing here. Yeah. Now first coin is head, first coin head, and second also head. Now for first coin head, already we have seen. Let us say first toss head. Sorry, I'm just interchanging the words. First toss head and second toss head. That is the A intersection B. Now for first toss head, let us say first coin I have selected. The first coin, fair coin, I have selected. With 1/3 probability I have selected a fair coin, and with 1/2 probability I got the head. Now that is for first head, first toss. Now there is second toss, right? So in the question what is asked, if the first toss is head, what is the probability that the second toss is head? With the remaining coins, now first coin is already selected, tossed. Now how many coins are left over now in the box? Only 2 coins are left, right? Isn't it? See, out of the 2 remaining coins in the box, 1 coin is then picked randomly and tossed. Now first coin you have, 1 coin you have selected in first toss you have done. Let us say you have selected first coin. Then afterwards only 2 are left. Again, to get head, what you need to select now? Now these 2 coins we have. With 1/2 probability we will select a coin, because in the box only 2 coins are there. Either unfair, this coin you will select, or third coin you will select. That is with 1/2 probability you will select. And suppose let us say you have selected the second coin. Now what is the probability that you will get a head? 1, right? Isn't it? If you select the third coin, there is no use, you don't get any head, only tails. So this one. Or else there is another possibility also. For first toss you have selected the second coin. So for the first toss you have selected the second coin. That means you have selected this coin for the first toss. So with what probability you will select? With 1/3 probability. Since there are 3 coins, with 1/3 probability you are selecting the first coin for first toss. Second coin you are selecting for first toss, and you are tossing it, you get a head. What is the probability to get a head? Already we have seen, since it is both the sides head, with one probability you will get the head. Now what are the, for second toss, already this we have taken out, only 2 we have. So with what probability we can select a coin? 1/2 probability. Now what is the, let us say which coin you have to select? Obviously the first coin, then only you will get head. With 1/2 probability you will get, select the first coin. And since it is a fair coin, what is the probability that you will get a head? 1/2. You got it right? These are the two possibilities, right? This is first toss head. Now first one coin is selected, first toss head. From the remaining coins, again to get a head, this is the one. Similarly this is another option, right? So total, if you see, what you will get, 1/12 plus 1/12, so 1/6 you are getting. So probability of A intersection B is 1/6. So what we want is probability of B intersection A we want, that is equal to A intersection B by P of A. So A intersection B, 1 by how much we got? 1/6, and P of A is 1/2. 1/6, 1/2. So how much you got? 1/3 is the answer. So option, yeah, 1/3, option B is answer. Have you understood? Is that my explanation is okay? Or if you have any doubt, you can ask. Other than Bunty, anyone have any doubts, you can ask. Bunty said he got understood it.
A intersection again.
Pardon? Can you repeat? Can you repeat?
P of A.
How to calculate P of A intersection B? Okay. Now P of A intersection B means, what is A actually? I said A is probability that the first coin toss is head. Sorry, I did not write properly. Sorry, A is the event, the first coin toss is head. 2 times we are tossing. We are selecting one coin and tossing. That is A. Probability that event that you will get a head when you toss the first coin. Now the first one coin you picked up and tossed it. Okay, that you kept aside. 2 more coins are left. Again you will pick a coin, you toss it again. Now B is second coin toss also head. So getting head in the second coin toss also, that is B. Now P of A intersection B means you have to get head in the first toss as well as in the second toss, right? A means what? Getting a head in the first toss. B means getting a head in the second toss. So that's what P of A intersection B means. Probability of getting head in the first toss, and also getting head in the second toss. Head in the second toss. Got it? Now what I am doing is, now from this we have 3 coins, right? We have already seen. This is the box. In the box you have 3 coins. 1, 2, 3 already we have seen. So first coin is head by tail, head and tail, fair coin. Second is both heads. Third coin is both tails. Now let us say first coin, you know already head. To get a first coin head, either you have to select, first toss head, either you have to select first coin or second coin you have to select. So first toss head. For first toss head,
1/3.
Pardon?
1/3. 1/3.
Yes. 1/3. Now selecting first coin is 1/3. Let us say I have selected first coin. Now I selected first coin. Now I tossed it with 1/2 probability. I'll get the head, right? Is that okay?
Yes.
Yeah, okay.
Yes. Yes.
Now with this is for first toss. Now for second toss. Now since already you have selected the first coin and had kept it aside, now only 2 coins are there, 2 and 3. These 2 coins are left in the box. Now again you have to select a coin. So when we will get head only if you select the second coin. So with what probability I can select second coin? 1/2, right?
Yes. 1/2.
With what probability I'll get a head now?
1.
1,
into 1.
because both are heads. This is for second toss. This is one way of getting first head and second head. There is another way also there. So I'm adding up another way also there. For first toss you are selecting second coin. So with 1/3 probability I'm selecting the second coin, that is for first toss. When I toss the second coin I'll get with 1 probability head. So this is first toss. And now since second coin is already taken out, only 2 coins are left, first and third. Again from that 1/2 probability I have to select the first coin, and
Into 1/2.
1/2 probability you will get the head. So this all equals to 1/6.
Okay, sir. Got it.
You got it right? Fine.
Fine.
Any other questions from anyone? Fine. Let's move on to the next question. Okay, this is also given in GATE 2021. This will come a bit later. Now this one, you see, this question is related to probability and information. This we will see definitely. Bayes theorem application only. And this question, you see, this was given in GATE 2020 ECE for 1 mark. A binary random variable x takes the values +1 or -2. So it's a binary random variable. 2 values it takes, either +2 or -2. The probability of getting +2 is alpha. P of +2 is alpha. Then what they are asking is the value of alpha for which the entropy of x is maximum. Just relating probability with entropies. You might have studied information theory, right? So we have a binary random variable. It will take 2 values. So let us say x is the random variable. It will take 2 values, either +2 or -2, just like a coin. So yes, 0.5 is the answer. Okay, correct. So what is given? Probability with which it take +2 is alpha. So probability with which we will get +2 is alpha. Then with what probability we will get -2? Can somebody tell me? We know total probabilities is 1. So what probability will get? Yes, 1 minus alpha. So with 1 minus alpha probability you will get a -2. Now what is entropy? You might have studied, right, in information theory. So the entropy definition you know, right? So entropy will say H sigma P of x into log 1 by P of xi, I equal to 1 to n. How many are there? Like how many different not random variables, how many symbols or whatever it may be, classes are there, right? Or else this only, sometimes they write like this: sigma P of xi into log P of xi. Okay, so here we have like 2, right? So I can write like minus sigma not required, directly I can write P of probability of getting plus 2 into log P of plus 2 plus probability of getting minus 2 into log probability of getting minus 2. This one, right? Okay. So later you can solve this if you if you draw for a binary one, I'm telling, if you draw a plot versus the probability, let us say the alpha and the entropy, okay, so the entropy of x for a binary one, if you draw it, you will get something, a parabola kind of thing, you'll get like this. It will have minimum at 0 and also minimum at 1 and maximum value at half. Okay, you can derive this later. So here this one is what? P of 2 is what? Alpha into log alpha plus 1 minus alpha into log 1 minus alpha. This you need to differentiate where you'll get maxima or minima something. So at half probability you will get maximum entropy. That is very well-known result in information theory. Okay, so for a binary random variable which takes two values, when the probabilities are equal, you will get maximum entropy. Here peak entropy you'll get when probabilities are equal. That's why in the question you can say the value of alpha for which the entropy is maximum is when there are equal entropy, that is 0.5. Okay, now this will be applicable even for not only binary, if other random variables also, like let us say a random variable is taking 4 different values or n different values, then when will be the entropy maximum? When they are equiprobable, all the occurrences are equiprobable. Okay, so when a random variable takes n values, n different values, that means it's like in communications you might have studied, right? QPSK or 8PSK. There QPSK means 4 symbols you will have. If 4 symbols having equiprobable, then the entropy is maximum. Okay, so what is the probability then? 1 by n. When the probability is 1 by n, when equiprobable means 1 by all, right? Then it will have maximum entropy. Is that okay? You just refer to information theory once. There is very standard result, this one. When the symbols or the different instances are, you can say when they are equiprobable, you will get maximum entropy. So that's why here only 2. So number of classes 2, 1 by 2, 0.5 is the answer. Okay, any other questions? Fine. Yeah, this question ECE. This question was given in GATE 2020 ECE for 1 mark. The two sides of a fair coin are labeled as 0 and 1. The coin is tossed 2 times independently. Okay, let M and N denote the labels corresponding to the outcomes of those tosses. For a random variable x defined as x equal to minimum of m comma n, the expected value of E of x is. So they're asking the expected value. Can somebody tell me what is expectation of a random variable? You might have seen expectation, variance, second moment, these things you might have seen, right? Expectation is nothing but mean. Yes, if x is a random variable, then its expectation or mean is given by, yes, if it is a discrete one, okay, if it is a discrete random variable, x is a discrete random variable, you know, right, we will have two types of random variables, continuous and discrete. Let us say coin tosses is kind of discrete random variable. Let us say temperature variations in a day, that is continuous random variable, continuously it changes, right? We will have two types of random variables. Then expectation of the random variable is nothing but the average value or mean. This is given by sigma xi into probability of xi. I is for all I, you can say whatever are that. If x is a continuous random variable, then what is the expectation? Integration, right? Integration minus infinity to infinity x into f of x, fx of x dx. This fx of x is what? Probability density function, PDF, right? What about px of I? What is this called? Probability mass function, right? In discrete case, PMF, right? Fine. So in our case, we have it's a discrete one, so we need to use tossing a coin is a discrete random variable, we can say, so we need to use that one. So let m and n denote the labels corresponding to outcome of those tosses. So we have a coin, it one side 0 and another side 1. Fair coin means with equiprobable you will get. Okay, now m and n denote the labels corresponding to the outcomes of the toss. So m and n, so independently, first we have tossed and second we are tossing, they are independent. That means the outcome of the second toss doesn't depend on the outcome of the first toss, that is nothing but independent. Okay, now random variable x denotes, x is a random variable, that is nothing but what? Minimum of m comma n, sorry, minimum of m comma n. Now what are the different possibilities? Let us say you are tossing the first coin, first toss you may get 0, second toss also you may get 0, right? And first toss you may get 0, second toss you may get 1, first toss you may get 1, second toss you may get 0, first toss you may get 1, second toss you may get 1. These are the probabilities, right? Sorry, labels. Now what is the x minimum of m comma n, right? What is the x minimum of m comma n? First case, what is the minimum of m comma n? Minimum of 0 comma 0. First case 0, second case also 0, third case also 0, fourth case it is 1. Now we have like 4 instances, 0 0 0 1 1 0 1 1. Now what are the probabilities? What are the probabilities now? P of x. Can somebody tell me? What is the probabilities? What is the probability to get 0 in the first toss? Half, right? Fair coin. What is the probability getting 0 in the second toss? Half only. So 1 by 3 into 1 by 3. Sorry, 1 by 2 into 1 by 2, 1 by 4. Similarly, what is the probability of getting 0 in the first toss? 1 by 2, 1 also same, all are same. So 1 by 4, 1 by 4, 1 by 4. Okay. Now if you draw the PMF for this, probability mass function for this, okay, so you have the random variable x here, random variable. So x is random variable here. It will take two values. What are the values it can take? Minimum value it can have 0, or minimum value it can take 1. Only two values. And 0, what is the probability to get 0? What is the probability to get 0? These three we need to add, right? 1 by 4 plus 1 by 4 plus 1 by 4, 3 by 4. What is the probability to get 1? 1 by 4. So this is nothing but P of x, PMF, probability mass function. You got it, right? So minimum value means here you will get only two cases, either 0 or 1. 0 will get with 3 by 4 probability, and 1 will get 1 by 4 probability. Now we got PMF, right? And also we have individual probabilities. Now I can calculate expectation of x is what? Okay, what is expectation of x? Sigma xi into P of xi, right? What are the two instant here? Random variable can take 0 or 1. So x can be 0, and probability that x equal to 0, plus x can be 1, and probability that x equal to 1, right? Either 0 or 1. Two cases. X is 0, then probability of getting x is 0. X is 1, probability of getting x is 1. X is 0, probability of getting x is 0 is 3 by 4, plus x is 1, probability of getting x is 1 is 1 by 4. So the answer is 1 by 4, that is 0.25. Is that okay? Is that okay? Anybody is having any doubts? Fine. Now, okay, one more question earlier kept, right? That will solve now. Yeah, this question was given in GATE 2021 and 2 marks. It's like combination of probability and information theory. They asked in a high school having equal number of boy students and girl students, okay, 75% of the students study science and remaining 25% students study commerce, okay, and commerce students are 2 times more likely to be a boy than are science students. The amount of information gained in knowing that a randomly selected girl student studies commerce is, okay. So some information they have given. They are asking the amount of information we have or gained, the amount of information it contains, knowing that a randomly selected girl student, you have selected a randomly girl student, she is a commerce student, she is studying commerce, okay. So information we know, right? Information, suppose information entropy relation also you know. Suppose a random variable x you have some probability. Okay, then information is given by log of 1 by p of x. Okay, this is nothing but the information. If x is taking, let's say, binary 1, so then information can be sigma log of, or if it is not only binary 1, anything, sigma log of p of xi. This is information. So that's what you might have seen in information theory. So based on the randomness, how much information we can get from that. Now just that is linked to here some probability kind of thing. So let us try to understand the question now. In a school having equal number of boy students and girl students, let us say boys I am saying B and girls I am saying G. So probability of B, they said equal number of boys and girl students they have. So probability of boys equal to half and probability of girls equal to half. And 75% of the students study commerce, science, and remaining 20% study. So commerce I'll say C and science I will say S. So 75% of the students study science. That means P of S I will say probability of science students is 3 by 4 and probability of commerce students is 1 by 4. Okay. Now what they're asking is commerce students are 2 times more likely to be a boy than are science students. That means commerce students, if you take, given a commerce student, they are 2 times of girl students. Sorry, what? Commerce students 2 times more likely to be a boy than are science students. No. Commerce students are 2 times more likely to be a boy than are science students. Wait. Commerce students are 2 times more likely to be a boy than are science students. Okay. Now let us say you have, commerce student. If given that a student is commerce student, that means also given that student is science student. That means a science student is a boy student and a commerce student is a boy student. Then commerce students are 2 times more likely to be a boy than a science student. Then what they are giving is this one. So P of B given C, that means in commerce students the percent of boy students you take, that is P of B given C. In science students also the percentage of boy students you take. Science student again you will have boy students and girl students. P of P given yes given B given yes, that is 2 times P of B given C is 2 times of P of B given yes. Now what they are asking is the amount of information gained in knowing that a randomly selected girl student studies commerce. That means what you want, a randomly selected girl student. You have selected a girl student, she is studying commerce. This probability we need to find out, right? The amount of information gained in knowing that a randomly selected girl student studies commerce. So if you select a girl student, then this girl student should study commerce. That's what we want. Now for this, if I find out log of or this one, then I'll get the required answer information. Okay. Now using the information given, how to get this one, P of C given G? How to get this one? Can somebody tell me? From this, how to get this one?
Base.
Yes, Bayes theorem. Now which one first we need to find out?
P of G given C we have to find.
Yes, P of G given C we need to find out. For that, first we need to find out P of C we need to find out, right? Now if you see here, yeah, sorry, if we see here, P of B, can we write like this? Probability of boys is how we can write? Since we know these two things, boys in terms of commerce and boys in terms of science, okay, see this in the information, this information is given. Now probability of boys equal to, can I write like this? Probability of commerce, a student is commerce student, and in that commerce student he is a boy. So probability of a boy means what? Probability of commerce student, selecting a commerce student, and in that commerce student he is a boy, plus probability of science student, and in that science student he is a boy. Can I write like this? Can I express like this? Total boys, probability of boys, can I express like this? Is that okay? Fine. Now probability of boys is 1/2, already we know, it's given, and probability of commerce is 1/4, and probability of B given C, this let us say variable, and probability of science is 3/4, and probability of B given S. From this relation I can say 1/2 into probability of B given C. Can I write like this, right? Now what we will get? P of B given C 1/4 plus 3/8 equal to 1/2. Can you simplify and tell me P of B given C is how much? 1/2 by 5/8. 5/8. 4/5, right? Yes, 4/5. So what we got is probability of B given C is 4/5, and probability of B given S is what? 1/2 into 4/5 from this equation, so 2/5. Fine. Now these things we got. Now actually what we want? P of C given G we want. For that, what else we need to find out? Now this also we have. Can I find out P of C given B? Yeah. Can I find out P of C given B? Can I find out? This how I can write? Probability of, why I want this is, just 1 minute. Yeah, what we want is P of C given G we want, right? This is required, right? P of C given G. Now for this, can I write like this? Probability of student is commerce equal to, I can express in the same way, a commerce student equal to, how I can express probability that he is a boy and probability that if he is boy, with what probability he can be commerce, and probability of girl, if he is given it is girl, with what probability he can be commerce, she can be commerce. So because we want P of C given G, we want P of C given G you want. So since we know P of C already, we know how much, 1 by 4. I can express like this: P of C equal to probability of boy, and if he is boy, what is the probability that he is a commerce student, again plus probability of a girl, and if she is given, if she is girl, what is the probability that she is a commerce student. Now P of C is how much? We have P of C is 1 by 4, P of B is 1 by 2, and P of C given B is not there, that we need to find out, plus P of G is 1 by 2, and P of C given G only we want, actually this one, right? P of C given G we want. Now what we, but this also required, P of C given B we want, right? For that purpose only I am calculating here P of C given B. Now P of C given B, can I write P of C intersection B by P of B, or else this also can be written as, you know, right, P of B given C into P of C by P of B. Is that okay? So in this equation, the last equation, so this is the actual required one, P of C given G we want, and in this, to find out this is also we need to find out P of C given B. So P of C given B, can I write like P of C intersection B by P of B, that is equal to P of B intersection C into P of C by P of B. This way we can write, hope you know this. Now P of B intersection C we calculated 4 by 5 into P of C is 1 by 4, P of C is 1 by 4 by P of B is 1 by 2, probability of boy is 1 by 2. So what you are getting is 1 by 10, right? So 1 by 10. So P of C given B is 1 by 10. So here we get 1 by 10. Now P of C given G by equal to 2 into 1 by 4 minus 1 by 20. So this is 5 by 20. So 2 into 5 by 20, 4 by 20, 2 by 5. So what we got? P of C given G is 2 by 5. That means if you pick a girl randomly, okay, what is the probability that she is a commerce student? That's what we got is 2 by 5. So this one 2 by 5 we got. Now what is the information? So they want information, how much information is gained in that event. So that is nothing but log 1 by P of C by G, that means log of 5 by 2 with base to something, you'll get information. Okay, I'm not sure, something you'll get. Is that okay? Did you understood the procedure, right?
Yes, sir.
1.32 bits. Okay. You mean first question means this question only, or somebody said, can you revise the first question means? Today's first question, Vinod. Okay, let us come back to that. Before that, anybody is having any doubts in this? So let me repeat it again. They have given P of B and girls probability equal, and science and commerce 3/4, 1/4, and also given boys in commerce is double that of science in boys in science. That means probability of boy given a commerce student is 2 times the probability of boy given a science student. Now we need to find out probability of if you pick a girl random, what is the probability that she is the commerce student? P of C given G, we need to find out. From that we'll find out the information. Now with this information, so finally what I want is this one. This one I need to find out. So to find out this P of C we will express P of C like this. Okay. So to get that one, what I'm saying, P of B I'm expressing like this. Probability of boy equal to commerce students given that commerce is a boy, science students given that he is a science student is a boy. So from this P of B given C we don't know, P of B given S also we don't know, but with this relation we are arriving at one variable and we are getting it something around. Okay. Now P of B given C we have, so Bayes theorem I am using. P of C given B is this one. From this we will get something. Now probability of commerce equal to, I can express boy in probability of boy into, if he is a boy, what is the probability is a commerce student. Similarly girl into, if she is a girl, what is the probability she is a commerce student. With that I am getting P of C given G, and from that information we are getting. This is the procedure. Maybe in this, maybe we might have done some calculation mistake. Maybe later you can check what is the answer and whether we have done correct or not. And Vinod, you can stay back. I'll explain the first question. And before that, if anybody is having any doubts, you can ask me, or else you can join the next class. Next session is going to start. And Bunty, actually you asked from the state space, right? So actually I thought of solving that question, but first I thought last week few members have asked about that random variables, right? That's why I solved them. This one we will try to solve in the next class. I will cover like some basics related to this also. What is state variable? Like what is okay na? So what is the input variables, output variables? What are different matrix A, B, C, D? All this will cover. Then we'll go back. Yeah, we know. If you don't have doubts, you can join the next session. That is going to start at 7 o'clock. Yes, I think Vinod has asked, right? Yeah. So the question is, a box is containing 3 coins. So you have 3 coins in the box. I think I already explained twice. One more time I'm explaining. 3 coins. First coin, let us say, second coin, third coin. First coin is a fair coin. That means one side head, another side tail. Fair coin means equiprobable. getting head is equal to getting tail. Okay, so for first coin, what is the probability that you will get head for the first coin? 1 by 2. 1 by 2 probability you will get head, 1 by probability you will get tail. Second coin, it's unfair coin, both the sides heads it is having, head. So what is the probability you will get head? Always you will get head. When you toss it, always you will get head. So probability of getting head is 1 for the second coin. Third coin is both the sides tail and tail. So what is the probability of getting head in the third coin? When you toss it, no way to get head, always tail only will get 0. Those are the two coin, 3 coins. Okay, now what is being asked is a coin is picked randomly from the box and tossed. Okay, so one coin is picked randomly and tossed. Out of the 2 remaining coins in the box, one coin is then picked randomly and tossed. Okay, now what they're telling is first one coin is picked from the box and it is tossed, and now how many coins are left? 2 coins are left. Again second time also, from the remaining 2 coins, one more coin is picked and tossed. Okay, first 3 coins are there, one it is picked and tossed, and second time 2 coins are there, one it picked and tossed. Now what they are asking is, given that the first toss is head, that means in first toss you get head, already given, that means you got first toss head. Then what is the probability that we need to find out? What is the probability that in second toss also you will get head? Okay, first toss head you got, what is the probability that second toss also you will get head? That's what we need to find out. Now what we are saying is, I am saying A is the event that first coin toss is head. When I am tossing the first coin toss, that is head. B is the event that when you tossing the second time, second coin toss is head. Okay, now what they are asking, P of B given A, that means given A means what? Already you know the first coin toss is head, then what is the probability that the second coin toss also head? See, first coin toss is head means second time you may get head or you may get tail. So in that only you want what is the probability that the second coin toss also head. That's what they are asking. So using Bayes theorem, I can write like this: P of B given A equal to P of A intersection B by P of A. We can write. So what is P of A? First coin getting head. So that's what first I am calculating P of A. To find out the required one, first I am calculating P of A. Now what is P of A? P of A is getting a head in the first toss. Now I have 3 coins. What is the with 1 by 3 probability to get a head? What is the different probabilities I have? I'm saying I can choose the first coin and toss it, or else I can choose the second coin and toss it, or else I can choose the third coin and toss it. Suppose if I choose the first coin, with what probability I can choose? First coin, 1 by 3 probability I can choose. 3 are there, either 1, 2 or 3, anything you can choose with 1 by 3 probability. Okay, now let us say I have chosen first coin. Now with what probability? Chosen first coin with 1 by 3 probability. Now I tossed it. With what probability I'll get a head? 1 by 2 probability, right? If I toss it, either you may get head or tail. So 1 by 2 probability you'll get head. Or another possibility is there. Let us say I have picked second coin. Second coin I picked with what? 1 by 3 probability. This is all for the first tossing only, first trial only. Second coin I can pick with 1 by 3 probability. If I pick the second coin, with what probability I will get head? With 1 probability, because If we second coin is both the sides head only, so you'll get head only. So one probability you'll get head. Let us say I picked the third coin with 1/3 probability you'll get third coin. You tossed the third coin. Third coin when you're tossing you'll get 0 head. That is for sure. So this is the probability that for the first toss getting head. This is P of A is what? Getting head in the first toss. If you add all these things, you will get something 1/2 you will get. Okay. Now what we require is this one. In this denominator we got. Now numerator we want what is that? P of A intersection B. Now what is P of A intersection B? Probability that first toss should be a head and second toss also should be head. Okay. First you will take a coin with 1/3 probability, you will toss it. It should be head. Then what? 2 coins only left out of 3. 1 we have taken. Now from the 2 coins, 1 coin again you will take. You will toss it. Again that also you need to get a head. That is the P of A intersection B meaning. First toss should be head. Second toss also should be head. Now again first toss should be head means, let us say first in the previous case, first I am selecting first coin. We have 3 coins, 1, 2, 3. To get head in the first coin, first toss, sorry, you are selecting first coin, let us say. With 1/3 probability, you have selected first coin and you tossed it. You will get with 1/2 probability, you will get head, just like what we have seen here. Right? Like this. First toss is over. Now second toss you come. First toss, first coin already removed. Now in the box only we have 2 coins, not more. In the box what we have? Only 2 coins. 2 and 3 we have. Okay. Now 2 and 3, with what probability you will select 1 coin? Second coin only we have to select, then only you will get head. So second coin you have selected with 1/2 probability because only 2 coins are there. In the box I have coin 2 is there, coin 3 is there. From 2, 1 you have to select, means with 1/2 probability only you are selecting. Second coin. If you select second coin, what is the getting head probability? 1, because both the sides head 1. So this is one way for getting head in the first and second tosses as well. Or else one more chance also there, one more way also there. Out of 3 coins, you come back to first. 3 coins are there. First time you selected second coin. In the previous case, first time I selected first coin. Now first time I selected second coin. Second coin, how much probability I can select? With what probability I can select? 1/3 probability I can select. If I selected second coin with 1/3 probability, now I tossed it. What is the probability that I will get head? 1. This one. This is first toss. Now first toss is done. Now what are the coins left now? Only 2 coins are left. That is first coin is left, third coin is left. First coin is head tail, third coin is tail. Now from this one coin you have to select. Which coin? You have to select, obviously to get a head in the second toss you have to select the first coin. Out of these two, with 1/2 probability you will select the first coin. Okay, you selected the first coin. Now what is the probability that you will get a head? It's a fair one. First one is fair one. Head or tail? With 1/2 probability you will get head. So now this is the whole thing. Another thing also there, another chance also there. Why I am not writing means there you won't get any heads. Suppose like first coin, second coin, third coins all are there. Third coin is tail and tail. First coin, second coin, this we have seen. Now in the third tail, let us say first time you are selecting the third coin. That means I am selecting the third coin with 1/3 probability. Now I am tossing it. Third coin, both are tails. 0 probability you will get head. Whatever may be the multiplication, this entire term will become 0. That's why I'm not selecting this. Okay. Now if you add this, this is, you will get 1 by 6. P of A intersection B 1 by 6. P of A already you got 1 by 2. Now if you calculate here, P of A intersection B is 1 by 6 by P of A is 1 by 2. So you will get the answer 1 by 3. Is that okay, Vinod?
Okay, sir. Thank you, sir.
Yeah, thank you. Fine.
Thank you a lot.
Yeah, we'll stop here. Thank you.